Okay, I think we've got everything sorted out so people on Big Blue Button can see it and people here can see. And it only took us 40 minutes. Sorry. Okay. So all good to start. And people online are good. So I was going to give a talk about GitHub Actions and what you can use it for some of your for various open source projects or various other things you might use GitHub for. Let's see, how does this go? All right. So what GitHub Actions is yet another continuous integration system set up for which integrates with GitHub. This time, rather than being an external service, it's something provided by GitHub themselves, and so it integrates nicely in the UI, and you don't have to sign up for any additional services to use it. The way it's set up, the way they're providing it at the moment, it is free for open source projects or anything else which you've got as a public repository on GitHub. And if you do have private repositories, there is a free tier available where you can use a certain number of minutes every month, and if you need more, you pay for it. So that's GitHub's model for to make money out of the system. By default, they provide you with free use of x86 runners, which will be running either Linux, Mac OS, or Windows. If you need anything else, such as a non-x86 Linux system, it's possible to run your own system and have GitHub send the jobs to your computer, which you could either use that to deploy an ARM if you want to test on ARM, or if you want to test on x86 but not pay GitHub for use of their servers. It's a bit annoying. I can't just sort of press a button to move forward. That's good. To create workflows, workflows are stored in your Git repository, which is kind of useful because they can be updated just as you update your code. You can update them through pull requests, etc. So if you place files in the .github/workflows directory, then and if those workflows are available on the master branch, then jobs will be automatically started based on whatever triggers have been set for them. Each of the workflows you create consist of one or more triggers, events which you want to, which your jobs will wait for, and then one or more jobs which will run in response to it. So the GitHub the workflow syntax is a simple YAML format. So this is basically just simple indentation and key value pairs. The trigger events are specified just as an on section, and this is just sort of this slide is just showing a very simple set of triggers where I might have a workflow which is going to be run whenever changes are pushed to the master branch of the repository, or whenever someone creates or updates a pull request. Those are definitely not the only types of triggers you can have. So you can run a workflow when someone pushes up a tag to the repository, whenever someone creates or updates a bug report on the repository. If you use the GitHub's Kanban system, which they call projects. You can also trigger workflows based on that. So, like, if you move a card to your done column, you might sort of trigger something to do something associated with that card. You can also run jobs on a cron basis. So if you wanted to do something every Sunday, you can have that workflow run then, no matter whether changes get made to the repository or not. It's also possible to externally trigger via a webhook, and you can also just have workflows which are triggered directly from the website manually. And there's copious documentation about all of the triggers and what they look like and the information they provide with them. In general, if you've ever worked with GitHub's API, it looks like the same webhooks, which you can use to be notified about changes remotely. So yeah. So in addition to the triggers, you've got jobs, which each job attached to a workflow represents some amount of work which is going to be performed on a single virtual machine. So when the job starts, the VM is started, and when the job finishes, the VM goes away. So you can basically do anything to that VM, install packages, and it doesn't matter. The state's going to all go away when the job finishes. In addition to running Linux, you can have jobs running on Windows or Mac OS. I guess the support for Windows is actually kind of nice if you've been using Travis, which supported Linux and Mac OS. So this one you can sort of trigger. You can try all three main platforms in one go, which can be kind of useful to write a single workflow which handles all of them. If you're running Linux jobs, you've got a choice of different Ubuntu versions, but if you want to test against Fedora or Debian or something, it is possible to ask for your job to be run within a Docker container, which means that you can basically test almost any library environment, any environment you can think of in that way. If you specify multiple jobs for your workflow, they can be run. By default, they will all run together at the same time. It is also possible to say that you can specify dependencies between the jobs, which can be useful which could be useful if you want to make sure that some cheap jobs get done first, followed by the expensive ones, which you don't want to bother running unless the cheap ones pass. Or alternatively, if one of the jobs makes use of an artifact produced by a previous job. So, but yeah, unlike Travis, where you've got to say explicitly which jobs do run in parallel, this one, everything's parallel unless you say otherwise. And it also supports a way of a matrix feature to allow you to parameterize a job and create multiple similar jobs easily without sort of repeating yourself in the workflow. So this is an example of what the jobs syntax looks like in the file. So in essence, you got the jobs section, and then underneath you've got one section for each of the jobs which you define. The important features we've got is so you've got the ID of the job, which here I've set tests. Runs on. I'm picking what particular virtual machine image we want to use. So here I picked Ubuntu latest, which I think at the moment is sitting on Ubuntu 18.04, but it'll probably be switched to 20.04 whenever. I mean, the 2004 image is available, but it's not yet picked as the default. Nick? So these images are provided by GitHub, and they control what they point at. But often, unless it's easy to sort of say, I want to check Ubuntu, for Ubuntu, I think at the moment they provide Ubuntu 16.04, Ubuntu 18.04, and Ubuntu 20.04. I think there are 1 or 2 Windows and 1 or 2 macOS images. I can't remember exactly how many, but yeah, in general, if you just wanted to test Linux, Windows, and macOS, you'd use these latest aliases, and you'll always sort of be moving to something current. If you want to check particular ones, you can do that, and it's possible that at some point GitHub's going to remove some of these old ones. They haven't done it yet, but the system is kind of new. Yeah, so that's the runs on thing is specify. Oh, another one, Nick. As a what? So it was the 1804 is available now. Yes. Was 1810 available as a document? So you can use any image. The question. I don't know if people online can hear these. So Nick's asking if any of the non-LTS releases of Ubuntu are available. So as far as the virtual machine images go, you can only use what GitHub has provided, which on the Linux side is Ubuntu LTS releases. As far as Docker containers go, you can use anything available on Docker Hub. So there are multiple Ubuntu releases. You can make your own Docker images if you want to build something based on an Ubuntu release or build something based on one of the Debian. If you want to customize one of the Debian or Ubuntu or Fedora or CentOS Docker images, you can have your workflow run inside that container. In this particular simple case, I'm not sort of using the Docker feature. I'm just running directly on the VM because that's the simplest option, and I didn't really care about it. So after that, each of the jobs consists of a number of steps which are run sequentially inside that VM. One of the other keys which I didn't show in that previous thing was the matrix option. In this case, you can stick the strategy section inside a job, and inside the matrix, you can define any number of keys, and then any number of values for those keys, and then your job will be duplicated once for the Cartesian product of those keys. So in this case, if I've got 2 values for each of the keys, then I would get 4 jobs. So value 1, value 1, value 1, value 2, value 2, value 1, value 2, value 2. So this, right? Well, this could be anything. So, for instance, as I just didn't get to it yet, I was saying that out of any of these keys which you set in the matrix, you can then substitute them into other configuration for the job. So common things, in the previous job, simple job I had, I said my job is running on Ubuntu latest. In my matrix, I could have operating system as one of the keys and say I want to test Ubuntu latest, Windows latest, and macOS latest, and then say runs on matrix.operating system, and then I'd get 3 jobs for each of those operating systems. Let's say that I'm running a Python. I've got a Python project, for instance, and I might use the matrix thing again to say I want to check on Python 3.5, 3.6, 3.7. Now, those two together, then I've expanded out into 9 jobs. So, and you can get a large number of jobs very quickly in this way. It's also, if you don't want to get this Cartesian product behavior, you can also specify sets, sort of individual sets of keys that you want to check. So you might say, I want to check Ubuntu with Python 3.5, Ubuntu 3.6, Ubuntu 3.7, and then I only want to check the latest version of Python on Windows and latest version of Python on macOS. You can do things like that. But again, as far as the matrix is concerned, it's basically just providing you a set of values which you can then use somewhere else in your job. And one of the nice things, unlike Travis, you can attach a matrix to any of the jobs in your workflow. So you can have multiple jobs which are being expanded in different ways to create the entire workflow. Okay. So the steps is a sequential list of tasks which can happen inside the job. The simplest case, you can have a step which just says to run a particular shell command, or shell commands if it's multiple lines. This will run in the default shell of the platform. So this is going to be Bash on Linux, I think Z shell on macOS, and probably the command CMD on Windows. But you can also pick an alternative shell if you want. I haven't shown that here. So if you want to run Bash on Windows, you can do that. I think that goes through WSL, but don't quote me on that. I haven't actually tested that out. You could even say that your shell is Python if you want to run Python scripts directly, but well, it's basically any command interpreter you could use for this. And the alternative to specifying commands directly with the run key is to say users and list the name of an action. So the actions are kind of the interesting part of the system, because rather than having to spell out everything you want to do in your job, you can reference an action which will perform some work on your behalf and then continue on to the next step. So I already started saying a bit of that. So one of the interesting things with the GitHub Actions is that pretty much all of the functionality is provided by Actions. There is very little built-in functionality on GitHub Action system. So whereas you might have systems like Travis and Travis Circle CI and stuff, which might sort of start your job by checking out your code into your workspace. Not even that is done by default for the GitHub system. So you might reference an action which will check out your code. And the nice thing about that is, if you want to check out multiple repositories as part of your workflow, you can just reuse that action, pass it a different repository name and a different directory to install, directory to check out, and it'll do that for you. Each of the actions can take a number of input parameters, and they can also generate output parameters. And you can use those output parameters as keys which you substitute into the inputs of subsequent steps, which gives you a way of sort of chaining together a set of actions. And each of the actions in a system, as well as the actions which are provided by GitHub themselves, it's possible to write new actions yourself, which use them for your own jobs, or for or you can sort of publish them for other people to use. Let's see, where am I? So I was just going over a short list of some of the actions provided by GitHub. So again, often most workflows you'll write sort of will start off by calling out to the checkout action. It's possible to package up some of the files which your job has produced and upload them using the upload artifact action. You can either use those just so that they're available for you to download from the web when the job is finished, or alternatively, you can combine this with the download artifact action to move files from one job to another. Because again, each of your jobs are running on independent virtual machines, so you want to make you can't sort of just leave something in the file system and expect it to be available to the next job. There is a cache action which you can use to preserve data between runs of the job. So let's say that every time you check code into master, you've got a Node.js project, and the first thing you do is you run npm install to download all of your dependencies. You could decide to cache the node modules folder containing all of those dependencies you've downloaded, and that means that if a previous job is run with a particular cache key, it'll just put that old version of the node modules folder in place, so your job will run faster than it would otherwise. Avoid sort of some of that network overhead. Nick? So as you can see, most of these actions, they're specified as some word / another word. This is actually the path to a repository published on GitHub, and the bit after the @ is a tag on that repository. So this is specifying a particular revision, a particular tagged revision of the code for that action. I did have a slide later on about a bit about that, but in general, the way GitHub manages their actions and the way they recommend other people do it is that don't change the behavior of the actions in an incompatible way. If you do need to change things incompatibly, tag them with create a different tag name. So for instance, the checkout action started off as checkout version 1. I believe the version 2, they did some things to speed it up by doing a shallow checkout, and they've got some input parameters where you can say whether you want shallow or not, but the defaults, they changed the defaults to be more, to be a bit more efficient, but it has the potential to break workflows which were working before, so they decided this is now the checkout version 2 thing. You can continue to write workflows which use checkout version 1, and they'll continue to work. And GitHub could publish checkout version 3, and a workflow using version 2 is going to work. And when you're ready, you could flip to the new version, see if everything works, then great. And if not, you can roll it back. And again, because the workflows are published as part of your repository, you could try to upgrade the actions in your workflow through a pull request. If your workflow is triggered on the pull request, then you're going to run through the workflow to see if it actually works with the new version, and if it does, click merge, and now everything happening on master is going to use the new action. Peter. Then you've got an invalid workflow. If you want to use the head revision, you might write @master, but that basically means any any attempt to provide sort of API stability on the part of the action author, you're giving up. So you probably don't want to write that, but you can. Let's see. So some other actions. There are actions which will install various tools for you. So they provide things for a lot of the common languages like Go, Node, Python, Ruby, Java, I guess a few others which they got in there. And one of the input parameters for those is the version of Python or the version of Ruby or whatever. So this is a prime target to use with the matrix feature. So again, if you set your matrix saying I want to run on these particular Python versions, then you might invoke actions /setup Python and pick those versions you want. There's various actions which are designed to manipulate pull requests or issues. So there is a labeler action which you could hook up to when a pull request is created, which you can provide it with a few rules to decide how to add some labels to the pull request based on the contents of the pull request. There's a stale action which you would often want to run, which you might want to run on a scheduled thing like every week or every month, which might look for issues which haven't been touched for a month or 2 months or something, and either close them or add a comment to it or something like that. Well, I haven't actually checked what the stale thing does. I haven't used that in any of my own projects, but
it's very
have you actually seen projects using this one, or? Yeah, that's probably different. So I think everything, every change which is made by the GitHub runners, it comes through, I think, saying GitHub Actions as the username or something. So that's probably something different. And first interaction is something which is designed to, again, something you might hook up when issues are created, to just post a nice welcome message or something, or same thing for pull requests. So like if the first time someone puts a pull request on your project, you might sort of want to remind them that we expect you to run the tests, or that tell them if you're using GitHub Actions to run the test suite, you might say, check to make sure you get a green tick when on your pull request. So because you might say, we're not going to review your code until the test suite passes, for instance, which, I mean, that's one of the reasons why you have an automated test suite. There's also a few actions which are created, which are related to creating and updating releases on GitHub if that's where you publish your releases. So yeah, again, as far as writing new actions, basically they are just GitHub repositories published to Git repositories published to GitHub, and you tag versions to say what you consider stable. The actions can either be based on Docker, in which case, when the action is called, it's going to build up it'll execute a Docker file to build up a Docker image, and then execute the entry point for your action within that container. Or alternatively, they can be based on Node, in which case they run on top of a copy of Node 12 inside the virtual machine without any container. So I've written a few actions myself. I found the Node.js stuff is probably the one worth looking at. There's a couple of reasons. The Docker-based actions, they are slower to run because, again, it's building up. It needs to download everything to build up the Docker container every time it runs. And even if if you're starting with a small container like Alpine Linux or something which is only might be 100 megabytes or something like that, that's still quite big. Whereas a Node.js action might be less than a megabyte or something, and it'll start up. And since it's running in the host system, there's no container to spin up as well. The other benefit of the Node.js based actions is that they'll run on all of the target systems, whereas Docker based actions will only run on Linux. I guess in the olden days, you might have picked something like Bash or something as a method of writing your actions, but these days Node.js is kind of you could think of it as being portable Bash, I guess. And for some reason, GitHub thinks having all of your jobs running on Windows is important. I guess maybe it's because they're owned by Windows, owned by Microsoft. So, what? Yeah, it is kind of nice that they've got a useful system which makes it easy to test your code on Windows. So I was just going over a couple of the possible ways you could build up a workflow. Just after this, I was going to show a couple of projects which have we built up some workflows. Let's see. So again, this was one of the ideas is if you've got a project where there's different people working on it, responsible for different parts. So you've got a documentation directory in your project, you might decide that you're going to tag any pull requests which touch the documentation directory with the docs tag or something, and then any of your project members, they can see which pull requests are worth their time to look at. Another one, if you've used GitHub Pages to publish a website, the default setup is using Jekyll. If you want to use some other site generator, one of your options is to configure the site to run off the GH Pages branch, and then have an action which runs anytime code is checked into master, which will run your site generator and then take whatever it creates and check that in as a revision to the GH Pages branch, and then have GitHub deploy that to your website. So if you want to run a Hugo website, or even if you want to write your own site generator, or you can do anything like that. So they're doing that via actions to publish. Yep. Or HTML. Yep. Okay. So another one, I did briefly mention that you can have a workflow which is manually triggered. So in this case, there'd be a button on your project page where you can say, I want to trigger the workflow, and you can provide a couple of inputs. So let's say that you'd sort of encoded the process you used to release your project. So you want to say, every time I release it, I'm going to tag the release. I want to make sure that the test suite passes. I want to generate a binary package. I want to say, if I'm doing Python, I might want to say I want to upload that that package to PyPy, or if it's a snap, if I'm creating snap packages, I might want to upload to the Snap Store, or if you want to, if you're creating Flatpak packages, you might upload to FlatHub, and you can might also publish the same stuff as a release on your GitHub project, and have this all set up so that because you're running your tests first, if the tests fail, then your release process fails and you don't end up publishing anything. So this could be a way that if you want to make sure that you're only putting out tested code which you know to function. So another one, let's say that you're using a language which where you're often locking dependencies. Either this is a common workflow for writing stuff in Node.js or with Python, or even if you're sort of using like Git submodules to pull in code. So maybe you want to say every week I'm going to check, is there any new versions? And maybe you might have that workflow fail if there are new versions, so you'll get an email about this. Or one thing I know some of my colleagues, they've got set up for their one, they've got a workflow so that it will actually update the dependencies in the branch and commit this to another branch and create a pull request pointing back at master, which has the benefit that if you've got a workflow which is also run from pull requests, you will actually check to see, does my code actually function with these updated versions? And if so, hit merge and it's done. So yeah. Anyway, these are some of the just some resources. I was going to spend the next bit just taking a look over some projects which are using GitHub Actions to show some examples of it in the wild. So I'm going to try doing screen sharing. We'll see how this works. So how do we? I was thinking I'd see if I can. So. Okay, is anyone who's online? Is this showing up? Okay. This is a simple Python project I've been running, so I'll just make the text a bit bigger so that it's easier to see online. So again, this is a fairly standard Python project. We've got a setup.py, which says how to build and run the project, how to build and package the project. I've got a single workflow here, which is run tests. So again, I've named it run tests. There's two triggers which will start the job. It'll be run on pushes to the master branch, or whenever anyone creates a pull request. I've only got a single job here, so it says that it's going to run on the latest version of Ubuntu. I'm using a matrix to run on two different Python versions, 3.6.x, 3.7.x. So it's picking the latest micro releases from those two versions. So Just to make things nicer, I've named the job using the version which I picked from the matrix. Oops. So the first step is to check out the code. Then the second step is to make a certain version of Python available. In this case, the version which I picked in the matrix, and x64, I don't know if I actually need that or if it's, I could probably pick that up from defaults, but anyway. Then I've just got a step which is running shellcode to install the dependencies. So in this case, I've installed a couple of apt packages because it's on Ubuntu, and install a couple of dependencies in the requirements.txt file via pip. And then finally, I'm launching my test runner through the setup.py script. So I don't know if I actually got it. See if there's any runs. So on the Actions tab, we can actually see a couple of the runs. So these are again, there's a couple of pull requests I have been ignoring, which I should have been checking up on. Let's see, here's a failed one. So it fails on Python 3.6. So again, on the left-hand side, we've got a list of all of the jobs which are part of the run tests workflow. In this case, it's one job for each thing expanded from the matrix I provided. On the right, you can just see the results of each of the steps in the selected job. So again, the first step was to check out the repository. The next step was to make the version of Python available. This one, I believe the way this one works, it actually is just updating the path to point to make a Python interpreter, which is already available in the runner, available to, so it'll call when you call Python or whatever. And then my install dependencies. So again, that's installing packages via apt, and then installing a few pip packages, in this case, Pyro and PyGObject. And finally, we're running all of the tests. Which seem to be failing on the add signal handler, test. So again, that's kind of nice. So in general, this means either that pull request has broken something or my project no longer works. So one of those, I should probably check that. If I could potentially have set up a scheduled job if I wanted to check every month that my code still works, that would be another way I could sort of be told ahead of time that there's something wrong. Let's see. One of the other projects I've been working on was I developed a couple of actions which can be used to used by other projects. So I haven't actually, this one hasn't been published to the marketplace yet, but again, the main, this is an action written in Node.js. So the main entry point for an action is specified in one of these action.yaml files, which again, just the important parts are specifies the set of inputs for the action and outputs, and this says run it using Node.js, and this is the entry point. So there is a JavaScript file which is produced there. Interestingly, I've got a set of actions defined for to run on this workflow defined to run on this repository as well. So the interesting part here is as an integration job, one of the jobs here is to check to see if the action actually works. You can reference an action which is in the same, which you've checked out into the workspace. So here I'm just running the action which is in the base of the workspace, which is myself. So in this particular case, I just this is an action which is designed to build a Snapcraft project to create snap packages, and I've passed an input parameter to say, because my Snapcraft project isn't in the base of the workspace, and then I'm using one of GitHub's provided actions to create an artifact afterwards. And this one I passed as an input to an input which is based on the output of the previous step. So in this case, my action has an output saying this is the name of the snap file, because the snap package includes the version number, so it's not always going to be the same. And this way, I can just tell it to upload that file as an artifact, so I can check it after it's run. And again, here I wanted to make sure that this action ran on a selection of different Ubuntu VM images on actions. So again, I've used the matrix feature. Yes, Nick?
Which file will upload?
So my action, it runs the package build program Snapcraft, which will spit out a file, package name _version.snap. And just to make things easier, so that you don't have to sort of guess what version number or whatever it is, I made the action provide an output parameter, which is the name of the package. So in this case, I assigned an ID to the steps called Snapcraft, and I can reference any of the outputs of that step as a parameter to a future step. So in this case, the upload artifact action takes path as an input, which is either a directory or a file which I want to upload to wherever. In this case, I just want to upload that single file, and so that I can check to see that things worked. And again, in this case, because I'm writing an action, I want to make sure that this will work on whichever virtual machine image the user decides to run it on. I've got an, yes? No. This is basically a bit of storage which is associated with the run of the action. So every time the action is run, so every time someone creates a pull request or updates the pull request or pushes new code, there will be a new run of the action, and each of those runs can have artifacts associated with it. So again, one of the things I wanted to check with this particular action was saying that it's going to work no matter which virtual machine image the other project decides to run it on. So again, I've used the matrix feature to pick 3 different Ubuntu virtual machine images, and I reference that in the runs on field, so that this splits out into 3 jobs.
With an action, that's very Inception.
Yeah. Who knows? I don't know what that is.
Something I invented. When you have a project, say you GitHub thread, within there you create a Django project called main Django app within that project.
Ah, right. So this is because Are you still using Python 2 where you don't have where relative imports are the default, or is this something else?
Oh, no, this is Django thing.
Okay. All right. So again, I can look at this is just one of the runs of of this workflow. Again, I've ended up with a run of the unit test. Then I got 3 copies of my integration job, which were running on building 3 different projects. And then I've got another 3, which was checking that the action worked on 3 different virtual machines. I could have collapsed those into a single job and had a matrix which listed both the operating system I wanted to run on and the path to the project I wanted to build, and I would have ended up with 9 jobs instead of 6. But in this case, I'm assuming that if one of the projects builds correctly on a particular VM image, then all of them will. So I didn't want to sort of just make extra work. So again, that's a fairly simple one. And again, I get a couple of warnings here, which are basically because I'm running a test. These ones are coming from the unit test job, which is generating warnings because some of my tests were intentionally creating warnings just to check that they were found. Okay. So another big project I work on is Snapd. They use GitHub Actions to drive a lot of the continuous integration. You can take a look at some of these runs. Actually, let's go via pull requests. That'll give us a better view. So in this case, we've got multiple workflows attached to the same project. So here we had, oops, why is that? So again, we've got this was sort of running we've got one job here, which is just doing a simple check to see whether someone's an existing contributor or not, or if they've got to sign some paperwork. There's another workflow which is just running some simple tests on macOS. So this thing, there's only a few features which are designed to work on macOS, so this is basically just checking that those particular features build and it can run those sanity checks. So again, this is checking that it can download a package and get a bit of information about the package. So that's all fairly simple. And then we've got the big one, which is the unit and integration tests, which is big. So in this case, we've got a couple of jobs. So there's the unit tests, which are relatively fast. So say how long this took. Succeeded in 8 minutes, so that's fairly fast. And then we've got our integration tests, which are running on various other systems outside of GitHub. So that one took 26 minutes. We've got these integration tests, these slow integration tests are set to run only if the unit test jobs before them succeed. And again, they're using a matrix feature to go from one definition for the integration tests to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 22 here, and then there's a couple of extras. So again, this, yeah, Nick?
So at this point, this is probably costing someone like 22 cents.
So in this particular case, A, this is open source, so that I don't think we would be paying for this, but B, all of the ones in this big test suite we are running on a hosted runner. So basically, it calls out to a machine in the canonical data center to run the tests. And in fact, the way things are set up, that machine then calls into another VM which is running the system we want to test on, because again, we basically just got one runner image for which I think is probably running some Ubuntu release, but we want to be able to spin up possibly multiple copies of Ubuntu, various releases of CentOS, Fedora, OpenSUSE, Debian, Arch, Amazon Linux. And yeah, this is sort of a bit of annoying. It's a bit of an annoying one when you run a test like this and it passes on everything but two platforms which I don't have access. I don't have a VM set up for locally, and you've got to track down, work out what's happened. But again, this is sort of an example of the type of large workflows you can create. I'll just get an example of the workflow. So again, here you can see there's three YAML files corresponding to the three different workflows which is running. The test YAML one, again, this is just set up so it's running on pull requests. We could probably set that so it runs on pushes to master, but at the moment we're just running these ones on pull requests and requiring that people have it passing before they merge. We're running the unit tests on one of the GitHub's provided runners. Then we've got let's see, and again there's a matrix to split up that unit tests run between running Go 1.9 and the bleeding edge version of Go, just sort of so we'll know if the next version of Go the project's going to break. So again, the actual project logic for that step is fairly involved. There's some caching stuff to try and speed things up, various things. Then we've got a second job here, spread, which says that it needs unit tests to run. So, and because the unit test job was matrixed out, it's actually going to depend on both unit tests jobs before it tries to run the spread tests. And this one says runs on self-hosted. So this means that it's a system which we're running a copy of the GitHub runner on some virtual machine somewhere, and it's registered against the project saying this is our project. So again, we're using a matrix strategy here to decide which of the next distros we want to test the project against. And again, go through checking out the code. And then eventually we're running the spread tests. So this is running the spread tool, which will spin up the virtual machines to run against, and we're making use of a secrets feature to pass in some secret information which is needed by that program in order to actually sort of spin up the virtual machines. So this is how we can have information which isn't checked into the into the virtual machine. Sorry, isn't checked into the repository, but is available when the virtual machine is running. And by default, at the moment, secrets are only available to project members as well. So, yeah, that sort of offers some level of, so there's a limit to how useful they can be for pull requests where you might be having community members, because it basically those secrets would only be available for pull requests from people that have already got commit access to the repository. But anyway. And in this case, at the end, we're doing something to just tidy up those virtual machines. So one of the tricks here, we've actually got a step which is set to run always. So usually there is a condition assigned to each of the steps saying only run if the job is currently successful. So the first failing step will prevent everything from running. But here we want to do this cleanup all the time. So we say run it always. So even if the tests fail, we'll tear everything down. And then we've got another job. I don't know what this one does exactly. I haven't had to care about this part of the project, but anyway, so that's sort of one of the larger example projects. Anyway, that's most of the stuff I wanted to show. Does anyone have any questions? For that spread one, see, I'll just stop sharing so we've got those resources back on. So the question was, how hard was it to integrate that into our workflow? So for the snapd project, we were previously using Travis CI. It was mostly, there was definitely some sort of kinks on the process of moving everything over, but as you can see, that project, we ended up with 3 separate workflows. We had some tasks which were kind of independent, so like that CLA check, contributor check, that didn't have anything to do with the rest of the tasks we were doing, so it was fairly easy to just port that as a simple job over as one of the first ones. The same goes for the macOS smoke test. We just essentially started adding GitHub Actions, which were duplicating what we were doing in Travis, and then when we were comfortable that they were functioning, we disabled that code in Travis. So I think for the big spread test, which is that ginormous integration tests, we started off running a couple of the spread jobs under GitHub and disabling them in Travis, and eventually we were happy enough that things seemed to be performing better under the GitHub runner, especially when we were using the self-hosted runner, that we just moved everything over and disabled the Travis jobs. Again, for a lot of my own projects where things have been fairly simple, it's once I had a feel for the syntax, you just write them out and it fails, so you change them, commit again, check it again, and eventually things work. And yeah, again, it's kind of, sorry, where are these VMs actually running? Chris asks. So if you do create a self-hosted runner, they will be running in your data center or at the end of your NBN connection or whatever else. I think I can probably, I can do screen sharing to try and show some of that configuration. I haven't actually configured self-hosted runners anywhere, so So let's see how we go. Nope, that's not it. Settings. So if I downloaded the GitHub runner and I started running it on one of my servers, I could click Add Runner, in which case I'd pick, I've got some instructions on how to set these things up. I think, yeah, so I say Linux x64. I'd basically, I'd download the program, I'd configure it. I've got a token here, which presumably this is a throwaway thing which would associate that runner with my project so that it'll receive callouts, and then I'd be able to reference that within my workflow. Again, secrets is I could also create new secrets here where this would be something assigned to the project. So it could be a nice big multi-line thing if you want to. I could have, if I really wanted to, I could put an SSH private key into one of these secrets. If I wanted to, say, have the end of my workflow involve SSHing into my server and uploading a new copy of the website, something that you could do something like that if you wanted. So that's just some of the types of things you could do if you want. But yeah, other than if you're not using a self-hosted runner, the VMs are hosted by GitHub themselves. They're hosted in the Azure cloud. I think somehow GitHub got a great deal from Microsoft for running cloud services on Azure for some reason. But yeah, in general, you don't really have, if you're using GitHub's hosted runners, then you don't really have to care. They're just there and they run fast, and yeah. Other questions? Let's see. There are some things which it would be nice to have. As I said earlier, the secrets by default are only available to jobs which are initiated by someone who has write access to the repository. It would sometimes be nice to have something which is available to everyone. I mean, that's obviously not a hard secret, because if anyone can sort of modify the action in a pull request and then have the pull request run the modified workflow, you could easily exfiltrate the secrets that way. But sometimes you don't really want to. You've got something which you don't want people to. You don't want to just be available in a Google search, but you don't care. You don't consider it that big a secret. In some cases, it would be nice to be able to have a secret like that. I think there's sometimes it would be nice if there was some pre-canned actions for various jobs which I haven't written. So again, I mentioned there's the ability for other people to publish actions. I may as well take a look in the marketplace, which we missed earlier. So, and I'll do the screen share again. So there's a whole lot of actions here. So, so is there any particular things anyone would be interested? Some type of action which someone would be interested in? I can see if that's available. D. I don't know. Would you usually has it got its own build tools, or would you usually?
Probably does. I'm just
I don't know. Is there something to do with Rust and cargo, or if you're developing a Rust project, this is an action which will run cargo on your to build your project, to build and release. Yep. I will say there's one aspect which I think some people sort of ignore when they're. One thing to be careful about with the third-party actions is when you sort of call out to a third party's action, you're essentially letting those people run arbitrary commands in the virtual machine which you're running. So if you were you want to make sure that you trust the action. So for instance, let's say that you're building a package and you want to upload it to PyPy, for instance, if it's a Python project. I think there are a couple of actions which can upload to PyPy. So here we've got one written by Ortega, whoever this person is. And then there's another one which is written by the Python Packaging Authority, who is the group of Python developers who run PyPy. I would pick this one because, in general, both of those actions, they could do anything to your package before uploading it. The PyPA guys, they could do anything to your package after you've uploaded it, so I would tend to trust that. But it's worth keeping in mind if you sort of rely on the security of any of the outputs of your job after a step which has used a third-party action, you probably want to be careful about which ones you sort of you trust like that. I don't know if there's a good solution to that other than just sort of saying don't just pick the first thing which comes from the marketplace. Sort of treat it as a potential security problem. So again, like some of the actions I worked on was stuff to build and publish snap packages, and again, we're publishing them from the same GitHub organization where the Snap Store, which is the tool to actually build snap packages, is published. This is the Snapcraft tool. So if you're trusting the Snapcraft tool from the Snap Core organization, then you should probably trust the actions which are provided by the Snap Core organization. There's no, you're not sort of trusting extra entities to make sure that your software is secure in that way. So I think again the ability for third parties to publish actions is sort of a double-edged sword, I'd say. Do we have other questions? I can't see I can't see on Big Blue Button easily without sort of going infinite. Oh, no questions there. So yeah. So again, Space Cubed is providing the venue for this event. They're awesome. If you need co-working space, you should check them out. Right, and plug events. When is our next event, Nick?
Well, we'll be having a plug this
27th of July at the Mighty Quinn. Where is that? All right, awesome. So hope to see people there.
And this time next month.
So next month we've got August 11th is the Raspberry Pi Jam and Workshop. So if you've got a Raspberry Pi and you've got some project idea, come along, and we'll be providing have a couple of stations available. Is that the plan?
We will also have a special guest in the form of mini Macs. Raspberry Pi classroom supercomputer, supercomputing center.
Wow.
So I'll be bringing along to show off some projector. You guys can play with.
All right. Yeah. So, and I guess we can probably have the Big Blue Button running next month as well for people who don't feel comfortable coming in person. Although it's going to be easiest to sort of get the most out of the Raspberry Pi Jam in person, unfortunately. So,
Yeah,
but
the plan is for any event that's hybrid hosted. Anything we can hybrid host, we plan to.
all right. Okay, cool.